So today we're gonna do a review of fractions and operations. So that's adding, subtracting, multiplying, and dividing. Um, and then we'll kind of recap. So this is really procedural, and I'll kind of go over concepts as well, just so you have pictures in your head. And the first one that we'll go over is multiplication, because multiplication tends to be the most straightforward one. So when you're multiplying, remember that you're doing sets of things. So for example, if I said, hey, what's 2 times 3/5? That's asking what's 3/5 plus 3/5. Okay, so multiplication is always repeated addition. And if you remember, whenever you're adding things together, and this will review a little bit about adding fractions as well. So 3/5 plus 3/5 is 6/5, which is also known as 1 1/5. And a picture of this would look like this. I have 3/5 of a brownie pan left. My brownie pans don't look ever so even. So I have 3/5 of them. Here's one, right? And my pink brownies are very yummy. And then I have another one because I have 2 sets of 3/5. So there's 3/5, and I have 2 of them. So they're asking how much brownies do I have? And if you can imagine taking this brownie set here and then recoloring it and moving it over here. So this one goes here, right? And then doing the same thing here. So now these 2 are gone, right? Because you moved them over here, like you repackaged them. And now you have a whole brownie pan plus 1/5 of a brownie pan. So that's what the answer means. So when you're multiplying fractions, going back over here, when you're multiplying fractions, you're really just multiplying numerator times numerator, right? 2 times 3, that's where the 6 comes from. And 1 times 5, that's where the 5 comes from. So now you know how to multiply fractions. So for example, if I said, hey, what's 4 ninths times, I don't know, 3 halves. So you're just multiplying across like this. So what's 4 times 3? Oh, that's 12. What's 9 times 2? Oh, that's 18. And then you simplify. So that's 2/3. What this means in fraction land looks really confusing, so I'm not going to show you the concept of it, although it does make sense. It does actually make sense if we use kind of like fraction bars. Okay, so that's how you multiply fractions. The parts that get really tricky are when we have mixed numbers. So like say for example, we go 2 2/5 times 4/7 or something. I don't know, making stuff up, right? And you're like, oh, just multiply the top times the top and the bottom times the bottom. You kind of can do that, but then you have to remember there's an invisible plus that goes right there. So you can do this. So I'll show you this in 2 different ways. So you have to kind of like think about this as I'm multiplying 4/7 times the 2. So 2 times 4/7. And then I'm going to add it to 2/5 again times 4/7. And this will work, right? So you just multiply across here. This is 8/7 plus, like this, right? 1. And then this is 8/35. And then you'll have to add these 2 fractions together. So more on this part later, but let's do it how kind of like most people are probably used to looking at it, which is they'll convert this number here into an improper fraction. So they say 2 2/5, how many fifths is that? I want to know how many fifths that is. And you're like, well, I have 2 whole pans of brownies. Imagine this was all full again, right? If this is all full, how many fifths do I have? And you're like, oh, there's, 5 here and then 5 here. So that makes 10. So I have 10 fifths. Plus these 2/5, That's 12/5. So the procedure there is 2 times 5 and then plus 2, right? And then now we can multiply this times 4/7. And our answer becomes, again, just multiplying across, 48/35, which is some number. For high school, just so that you know, most high school teachers will like improper fractions because they're actually easier to deal with than mixed numbers. So I would see, can I simplify this? 5? No, nope, this is our answer. And so I'd leave it just like that, 48/35. And so we'll show this answer. We'll pause on this part because it actually will come out to be 48/35. And then just in a little bit. So this is how you multiply. So multiplication of fractions, all you're doing again is you're just taking the numerator and multiplying across, the denominator and multiplying across. So numerator times numerator, denominator times denominator. And you just kind of, it's almost like two problems, right? They're just having you keep them separated. Okay, so that is multiplication. Dun, 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 dun. Let's write multiplication up here. So then I'll move on to division, because division is kind of like it, except for you just have to remember this one rule and then you're good. So division problems, if you don't recall, division and multiplication are closely related. They're almost inverses. They're actually inverses of each other. And I'm just going to remind you that, like, if I take 10 and I divide it by 2, right, that's 5. But if I take 10 and I multiply it by 1/2, that's also 5. Okay. So here you can kind of see that the 10s stay the same. The answer stays the same, 5 and 5. And what happened here with that number? And so, some people will say, oh, it reciprocaled each other, it flipped, something like that. And then also what happened here to the division, it turned into multiplication. So when you divide by a fraction, so division by fractions is really just multiplying. Did I spell it right? Multiplying. Oops, I forgot a Y. Multiplying by the reciprocal. And the reciprocal means handstand. The fraction, the top goes to the bottom and the bottom goes to the top, just like when you do a handstand. Okay, so if I wanted to divide, I don't know, 10 divided by 1/2. The picture on 10 divided by half, it looks like this. If I have 10 brownies, I don't know why. I should have chosen a smaller number, but that's all right. So I have 10 brownies. These are all the same size, if you can pretend, right? And I'm going to divide them in groups of half, meaning I want to know how many half brownies I have. So I'm going to cut each of these brownies up in half. And I want to know how many half brownies do I have. And you're like, oh, okay, I could do this. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So the answer here is 20. And it's all because of this here. So let's try using this rule. So the 10 stays the same. That division symbol changes to, good, multiplication. That 1/2 changes to, yep, a 2. And 10 times 2 is 20. These two statements are equivalent in math, meaning they say the same thing. They say the same thing, okay? Okay, so whenever you're dividing by a fraction, you're really just multiplying. Again, the hardest ones will be like if they give you some kind of like mixed number, but you know how to deal with that because it's the same thing that you do over here. Okay, so that is multiplication and division. Now adding and subtracting, I'm going to group together as one because really they're just the same. So Let's do, hopefully you guys can read my writing. Okay, so adding and subtracting fractions, the way it works is in order to add things together, and this is true in just your everyday world, is whenever you're adding things together, they have to be the same. So think sorting laundry, putting away groceries, all of these things, you group things together, right? So, like, for example, I don't put socks randomly in my drawers. I put my socks in my sock drawer that sits next to my undershirts, right? Or all the pants go in, for my sons, go in one drawer or they get hung up, right? They're all grouped together. So when you're adding things together, they have to have somewhat of the same kind of thing. Um, oh, Give me a second. Let me just charge my iPad. I got it. Okay. Then, so same is true. So like if I'm thinking about like how many cookies do I have? Well, I've baked, 12 so far, and I'm supposed to bring 36. How many more cookies do I need? So that's going to be 36 minus 12. That's 24 more cookies, right? So 36 cookies minus 12 cookies is 24 cookies. So the same thing is true with fractions, except for the thing that has to be the same is the denominators. So that's why I paused at this problem, because our denominators here and here are not the same. So because they're not the same, I need to figure out a way to make them the same. So let's just start off with 4/5 plus 2/5, right? So we already kind of dealt with this problem up here. Kind of, this was 3/5 plus 3/5, that's 6/5, right? 4/5 plus 2/5, here we are not going to add across. We're going to keep the denominator because the denominators are the same. And then we're just going to add across the top, which is 6. So this is 6/5. So again, the picture on this, so I have 2 pounds of brownies. I have 4/5, oops, I don't want to use that color. I have 4/5 of a brownie in here. I have 2/5 of a brownie pan right there. Can you imagine me taking this one piece and putting them over here? And now I have a full pound of brownies with one left, which is what that equals, right? So that's the same whether I'm adding or subtracting, okay? They have to have the same denominator. If they don't have the same denominator, that's where our work really begins. So let's start off with, let's do like a 2/3 minus 1/6. Okay. So like, let's look at that really quick. So the picture that I want you to think about maybe is, again, brownie pans. And sixths to me look like this. Thirds this way. Okay, so we got 2/3 here. And we need to take away 1/6, which looks like this guy right here. So the first thing that I want to do is I can't just take away one of the pieces. The answer here is not 1/3, right? So the first thing that I want to do is I want to cut the first pan so that it matches the second pan. Now I can take away this one piece, and now it's clear I have 1, 2, 3 out of the 6 left. Okay, so what did we just do? We changed this fraction and wrote an equivalent fraction. So we said instead of writing 2/3, we could write 4/6. And this is true because look, I can multiply here by 2 and here by 2, and it becomes that. So one of the things that I would teach my students is, some people call it the big one. Let me show you what I mean. Here's that big one. My students would say that it looks like a half t-shirt. So I'm putting 2 over 2. What's 2 divided by 2? You're like, oh, that's just 1. So really, I'm not changing the value of 2/3. I'm just changing the look of 2/3. 4/6 and 2/3 are exactly the same. Just like if I had to pay you $20, but I didn't have a $20 bill, can you think of other ways that I can pay you $20 besides a $20 bill? Yeah, you're probably saying maybe two $10 bills, or maybe 4 $5 bills, or maybe one $10 bill and 2 $5 bills, or a lot of quarters. So all of these are equivalent to $20, but each of them look different, right? So that's what I did. I just changed the look of 4/6. So now instead of writing 2/3, I'm going to write 4/6 minus 1/6. Now you might be thinking, okay, but how did you know to multiply by 2? Well, here's where the work is. If I think about the numbers 3 and 6, I want to think about a number that both of them would go into. A number that both 3 and 6 would go into. So the way my brain works is I start off with the number 6 and I start writing his multiples. So 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18, and so on. And I'm really asking myself, does 3 go into that number? Right? And the answer is yes for 6. So now I'm thinking, okay, since it's yes, then I'm thinking in my brain, 3 times what number gives me 6? And you're saying, oh, it's 2. Well, that's where that 2 came from. Okay, so that's what the concept is. And so now let's just do some work to work on common denominators. And so I'll just say, of all these operations, multiplication, division, adding and subtracting is going to be your most task. It's the task heaviest. Because here in multiplication land, you're just multiplying across. Yes, you'd have to change from a mixed number into a improper fraction like we did here, but that's not too bad, right? Division, your biggest task is remembering the rule to multiply by the reciprocal. For adding and subtracting, it makes a lot of sense, right? The biggest mistake that people will do is like, oh, I'm just going to add across, and that doesn't work, right? It doesn't work. Because if that worked, then you could do something like this, right? If I had, like we said here, two $10 bills, well, a $10 bill, right, plus a $10 bill, right, would be 2, and then you would add the tens together, and that doesn't work. You have here $20, right? But when you add those 10 togethers and you say, oh yeah, I have two $20 bills, no, you don't, right? So just keep in mind, don't ever add the denominator. So let's write that pretty big. Don't add denominators. You don't ever get to do that. That's like illegal in math, like big no. Okay, so let's do another problem. So let me look up a couple of good practice problems because it kind of does matter. Fractions. Okay, here we go. So let's do another one that we did. Let's have you practice. Can you do 1/4 plus 2/12? So you're going to practice this. You're going to pause the video, and then you're going to come back to me when you think you have the right answer. Now you can keep playing it, but for me, I'd rather you pause the video. So pause the video. Okay, hopefully you're back. So let's do this wrong. This is wrong. Let's put this in red. The wrong way to do this, do not do this, right, is let's just add across the top. So 3 over 16, wrong. This is wrong. You can't just add across the top and the bottom. Remember, we said in big words, do not add the denominator. All right, so what do we do? So the first thing that we're going to do is we're going to try to figure out what the common denominator is. So I take the bigger number, I take 12, and I start writing out its multiples. So, and then asking, does 4 go into 12? And the answer is yes, 4 goes into 12. Since it's yes, then I ask myself 4 times what would give me 12? And then you're like, oh, it's 3. So that's going to be my big one. So I'm going to multiply by 3 over 3 here. And you remember from multiplication land that we're just going to multiply across. So 3 times 1, that's 3. 3 times 4, that's 12. And I'm very excited right now because now I have a common denominator, right? And because I have a common denominator, that means my denominator stays the same. And I just add across the top, so my answer is 5. Okay. So some of you are pretty good at figuring out what your common denominator is. This is really finding the least common multiple, if you've ever heard that. And if you can't find a number that both of them that really quickly, I'll show you my little trick. So here's 2/3 plus 3/4. So this is if you can't find a number that both of them go into and you can't think of it. Then what I want you to do is I just want you to multiply 3 times 4. I want you to multiply our denominator times our denominator. So to find my least common denominator, I multiplied 3 times 4, which is just 12, right? And that's going to be my denominator down here. That's going to be 12, and that's going to be 12. And now I'm thinking, how can I get 3 to be 4? Right? Like I'm thinking 3 times what gives me 12? I think I said the answer. It's times 4, right? So because I multiplied the bottom by 4, remember, we're going to multiply the top by 4 because we can only multiply by 1. So this has to be 8. Can you do the same thing over here? Can you tell me what goes in our big 1 here? What number would go in there? All right, hopefully you said 3. So then this would be a 9 because 3 times 3 is 9. And then now we have our answer of 17 over 12, which for me is a perfectly acceptable answer. Some teachers, depending on what grade you're in, are going to make you convert that into a mixed number. Or if you're in a word problem, you would never say, can I have 17 12 yards of fence? You don't say that. So you would say, can I have 1 and 5 12 yards of fence? So hopefully this makes sense in terms of least common denominator. Again, the biggest thing for you to remember for adding and subtracting is you can't add the denominators and they have to be the same. The denominators have to be the same in order to add them together. For multiplication, we just multiply across. For division, we multiply by the reciprocal. Hopefully this makes sense. All right, have a great day.